Hi there, my name is Martin Kelson. I want to introduce you to a little project I did yesterday. You might know from my blog and some of my other postings I'm really interested in home automation. But I'm interested in home automation you can stand to live with, so home automation that presents a tolerable user interface on the whole. And one piece of that to me is voice control, the ability to have a vocal dialogue with the software system. Because I don't always want to be fiddling with my phone. I don't always want to be getting up or moving to a control point. So voice is, to me, part of the solution. So what I've done is I did a quick one-day project here on putting together Gadgeteer, Raspberry Pi, Windows 10 IoT, AllJoyn, and Cortana. And all the pieces went together pretty easily. So I want to give you a quick walkthrough on what I've done here. We'll look at the code, we'll look at the demo, and we'll look at the hardware. But first off, I got to say this. Every home automation project you do, in fact every project you do, but especially home automation project, you're responsible for safety not only of yourself, but everybody who's going to come in contact with this project after you. So please keep that in mind. Here's a few guidelines. Make sure things run in a fail-safe fashion. Everything fails gracefully. And if you don't feel comfortable with the line voltages, if you don't feel comfortable with some of these things, then enjoy the video, but please don't try the project on your own. So let's talk a little bit about the architecture first. What we're putting together here is going to live on 3 different systems. It's going to live on a Raspberry Pi, which is this piece in the far right here. What we're going to do is we're going to build on top of the Windows 10 IoT Core, which was released a few days ago. You can I'll pull that down from the Microsoft site. I have a list of resources at the end of the video. And on top of Windows 10 IoT Core, we have something called AllJoyn. It is part of a system originally put together by Qualcomm. It allows for a bus, a communication bus within your home network for controllers, producers, and consumers to interact. On top of that, we're going to create a relay control service, which is a type of service that in AllJoyn parlance we would call a producer. It produces some service that other components can consume. And that relay control service is also going to make use of some hardware drivers put together by GHI and a few additions that I've made, and we'll walk through all of those as part of the code walkthrough. So that's our actuator node, and that's one little piece of hardware that's going to set off by itself in a corner somewhere. And the scenario that I'm doing here just for demo purposes is controlling a light and a fan. So the light and fan will actually be connected to that relay control service. Then on the left side of the screen over here, we have 2 copies of a voice command service. Now we're sitting on top of full Windows 10 implementations. These are considered consumer, in the AllJoyn parlance, consumer services. They're consuming the service that the relay control service is providing. The voice command service will actually be a Cortana enabled program. I can talk to Cortana on my desktop, and in fact I don't even have to run the app. Cortana will always be listening for certain keywords, and when she hears those keywords she's going to activate our app, and that app then will talk through AllJoyn and it'll issue commands that affect the state of the relay service, turning relays on and off and so forth. Now what you see here is you see a Windows 10 phone and a laptop component, but those are not 2 different versions of the same program. That's not a Windows 10 phone version of the desktop program. Those are actually the same, it's actually the same source code for both of those, and it'll run unaltered on both of those two devices. So let's take a little look at the hardware. I'll give you now a quick walkthrough of the hardware that I'm using to build this project. Okay, so here's the hardware we're going to be using. This right here is just your basic Raspberry Pi 2, and what I've done with this Raspberry Pi 2 is we've added in a Raspberry Pi Wi-Fi. Right now it's the main and perhaps only Wi-Fi that's supported by Windows 10 IoT Core. So you need to make sure you get one of these. There's a number of different vendors out there for these. but it's the one that's white and has a little picture of a raspberry on top. Then also we've got an SD card in here. And this SD card, I've gone ahead and followed all the instructions on the Windows developer site, and I've installed Windows 10 IoT Core there. I've changed my admin password and configured the Wi-Fi, gave it my SSID and so forth. So the only wired connection we're going to use with this is power, and that'll go on the small USB port right here. I'm going to use a wall power adapter, so we're not going to be connected to another computer other than through wireless. Now, most times when you would do a Raspberry Pi project up to this point, you would connect up to this 40-pin header here. And that can be a little problematic. First off, it's a male header, so you need jumper cables or a ribbon cable to put on there. And then most people, when they did Raspberry Pi projects, they would bring these 40 pins out to a proto board and then use jumper cables to connect up to their whatever their circuit is. And that's not the most rugged way to set things up. First off, there's a lot of electrical characteristics you have to take into account when you're doing that, in terms of the voltages that are available or tolerated on these pins. And working with proto boards and jumpers is not a very rugged solution. So what I've done is, through our friends at GHI, now I've got this all mounted on a GHI Holy board, which is a board that just has these regularly spaced holes, which works great for most things, but the Raspberry Pi is just a little bit off there, but everything else fits fine. So what I've added to that is, on that 40-pin connector, make sure I get that seated correctly. Double check, everything's good. So I have a product called a Fez Cream. All the letters I'm sure are upside down for you there, but this is a Fez Cream, and what that does is it connects to the 40-pin header and then adds a small subsystem here so that you can use Gadgeteer plugins with it. Now what Gadgeteer is it's a series of, it's a standard for interconnecting with peripheral devices. And it allows you to use peripheral devices that use analog ports, GPIO binary input-output, PWM, I2C, SPI buses, and so forth, without actually having to figuring out the pins that are here on the Raspberry Pi. You just need to plug in these little 10-lead connectors and connect them to your device. Now, the one thing you do have to pay attention to is not all of these connectors are created equal, so you have to, for a given device, you might have 3 or 4 different connectors that you can plug into, and just match up the little letters here, S and X for instance, and then match that up with, here we have X and Y, so I know that I can plug this device into a matching X connector. Now, there are quite a few Gadgeteer devices out there. You can do a lot of interesting things. There's joysticks and buttons and relays and temperature sensors and all the usual suspects. But in addition to that, you can get little breakout boards and adapters and so forth, and hook up pretty much anything to these Gadgeteer connectors. At some point, you know, you might have to resort to a breakout connector or something that brings it out to pins and connect to a device that doesn't have this 10-pin connector to it. But I've been pretty hard-pressed to find anything I couldn't connect to a Gadgeteer board so far. So that gives us the ability to connect up these Gadgeteer cables. So what I did then is I added a button, a little push button here. That's going to fire an event in my service. And then I have these 2 relays, and the reason I have these 2 relays is I want to actually control the power to 2 line current devices, a light and a fan. And I'm probably not going to hook those up in this video because I think you get the idea here. But you have 3 connectors, 3 screw-down connectors here. And those 3 screw-down connectors are a common tap and a normally open, normally closed connector. So using one pair of those, the connection is closed only when the relay is activated. Using the other pair, the connection is only closed when the relay is deactivated. Now again, I'll issue my warning here. So I'm not going to go ahead and hook these up. These relays actually have a little green LED on here, so we'll be able to see when they're active, and I think you'll get it. I don't have to actually hook a fan up to it, but the idea is that you would put a hot lead in the center and then a hot lead on the normally open, run that out to your fan, and whenever the relay is activated, then that circuit would close and your fan would turn on. So one of these is going to represent a light, one of them is going to represent a fan. I've hooked them up to the correct leads here, and now let's do some software. Alright, so let's do a quick demo here. What I've got here is I've got a Windows 10 phone, and I've got the circuit that I showed you earlier. It's all set up and it's running. Red light there. We're plugged into USB power through a power brick in the wall. We're talking to the network through Wi-Fi. Here I have a Windows 10 phone. It's also connected via Wi-Fi, and it's running my control point app. So the Raspberry Pi is running an AllJoyn service that serves out these two relays as controllable devices. It's a provider. This phone is running the consumer code. Let's see if we can get the two to talk to each other. So I'm going to click on Cortana here. And this is going to be interesting because I'm wearing a headset and I'm going to try and talk to Cortana, and hopefully you'll hear it too. So let's see how this goes. I know it's hard to see the screen, but hey, this is about voice. Oasis, turn on the light.
Turning on the light. Okay. I turned on the light.
Okay, so you can see she turned on the relay that I'm using to represent my light. Let's turn on the fan. It's getting hot in here. Oasis, turn on the light. Well, I did that already.
Turning on the light. Okay. I turned on the light.
Oh, she must think I'm some kind of idiot. The light's on already. Alright, let's turn on the fan. Oasis, turn on the fan.
Turning on the fan. Okay.
And there the fan is on.
The fan.
Let's turn them off. Oasis, turn off the fan.
Turning off the fan. Okay, I turned off the fan.
Oasis, turn off the light.
Turning off the light. Okay, I turned off the light.
Alright, so it doesn't get any simpler than that. Basically, I'm using my phone, I'm using Cortana, I'm speaking the commands go through AllJoyn. The relay node picks up those commands and then acts on them by controlling the Gadgeteer board. So you probably noticed that I used the word Oasis when I was giving a command through Cortana. Cortana's voice system has to have some way to know that you're talking to your app registered under that command, and not just asking her to do a web search about that topic. So I called my home assistant Oasis, and whenever I say Oasis followed by a command, or I use the word Oasis at the end of the command, it'll run my program and interpret it in the context of the commands that I registered. So we'll go into that further in the software. This is the end of part 1, which is the architecture and demo. In part 2, I'll walk through the software in some detail, show you how I created the Gadgeteer components, how I layered, how I used AllJoyn to register those as a service, and then also how to debug your service with the AllJoyn Explorer, and how to add AllJoyn to a control point app and use Cortana to drive that consumer. So that's the end of part 1. Here are some resources if you'd like to read in the meantime, waiting for part 2. Reference to the source code. You can find Gadgeteer hardware and a very friendly community at the GHI Electronics website. Windows Developer Center is your home for all things Windows and Windows development. The AllJoyn Explorer, which I'll cover in detail in the next session, is at the link shown there. And you can always follow my blog for announcements of new videos, topics, conversations, all sorts of random stuff related to Internet of Things. Thank you for sticking with me through part 1, and hope to see you in part 2. Thank you.